It's another math day here with teacher Jenny. Join me for another topic, and this time we are going to talk about linear and angular measure, in which time we are going to look for the radius. So finding the radius of a circle whose angular measure is 30 degrees and a linear measure of 60 meters. So again, let's try to take note about the given. We are given with a 30 degrees here, that is our angular measure. And we are given a linear measure, which is 60 meters. That is our S, or the arc length. So we are looking for the radius here, and then making use of our equation S is equal to theta R. Logging in the information, we've got 60. And again, you may omit the unit so that you will not be confused, and put the unit back later on. This will be equal to, our angle here is in terms of degrees, so we have to consider that our angular measure must be always in radian because we're using this equation. So we convert this into radian measure. We have to multiply that one with a pi over 180 degrees so that we can cancel the degrees in there, and the unit of measurement there is in rad. So getting the GCF between 30 and 180 degrees, we've got 30, so we have this divided by 30. This is 1, while 180 divided by 30, this is 6. And this 1 here is understood with 1 as the denominator. So multiplying that 1, we have 1 times pi, that will be a pi, over 1 times 6, that will be a 6. So we have now the angular measure, which is pi over 6. And then we are multiplying that one with r. Now, since we are looking for r here, and we've got a fraction beside that r, or multiplied to that r, all we have to do is to get that out, so that, or make that into a 1, so that we cannot see any visible number beside r. So, making this one into 1 is to simply multiply that one with a reciprocal of the pi over 6. Reciprocal meaning to say we have to flip the numbers. So we have pi over 6, the pi goes down, while the 6 goes up. So multiplying that one here, and multiplying the other side, so that we don't change the given originally. And then simplifying, this will be a 1 already. So we are left with an r here, and then 6 times 60, that will be at 360 over a pi. And then, we've got now our r, which is equivalent to 360 over a pi, with the unit, which is a meter. Now, some of you might be thinking that we can cancel our pi answer with the 360 there, because you might be thinking that that is 180 degrees. No, it's not, because this is already in a radius. We are not taking this one as an angle. Our value there is a radius value, so we do not consider a pi there as a 180. We only consider a pi as 180 there once we have that one under angle, and we are trying to convert angular measures. So let us now go to the next example. We have an arc of length 30 cm is intersected by a central angle of 6 radians in a circle. What is the radius of the circle? So again, let's try to take note about the given. The given information are the following. We have an arc length of 30 cm. That means to say we have an S, which is equivalent to a 30 cm. And we have a central angle of 6 radians. So that means to say that is our angular measure. We have that as 6 rad. And we are looking for our r. So r is a known. Using our equation, we've got our S equal to theta r. Plugging in, our S is 30. And then we've got our angle as 6 rad, or 6 alone, multiplied by 3, dividing this by 6. And so with this one, we are now left with a 5 here equal to r. Now take note, we did not bother converting the 6 rad there because it's already a radian measure of the angle. So that's why we're plugging in that one directly. So we have now our radius as 5. Let's try to put back the unit similar to the arc length unit, which is the cm. So this is now our radius. We have 5 cm. So this is how you are going to solve for an unknown radius given the angle and the linear measures. So once again, this is your teacher Jenny. Don't forget to like, share, and subscribe for more videos.